All right, this is lesson 34, talking about equally likely outcomes. So if I have an event E, which we talked about last lesson, if I choose a element from E at random, then each one of those elements have an equally likely chance of being selected. So the probability of an event E in an experiment with sample space S where each outcome is equally likely, so not one, no one of them doesn't have, more weight than the other one per se, is given by this. P of E, that's the probability of E, is the number of elements in E, that's the event that we're talking about, divided by the number of elements in S. So if I have a certain subset of a sample space E, and I want to determine the probability of me choosing something from E when I choose something from S, the probability is given by the number of elements in E divided by the number of elements in S. And this probability has to be between 0 and 1 since E is always a subset of S, so it's possible that E is empty, which would give us probability 0. It's also possible that E is all of S, in which case the probability would be 1. But this probability does have to be strictly between 0, or not strictly between, but between 0 and 1. So, in our first example, suppose I roll a fair six-sided dice. Determine the following probabilities. So if I roll a six-sided dice, each one of the sides, 1, 2, 3, 4, 5, 6, all have an equal chance of being rolled, right? So here my event is rolling a 5. Well, what are the chances of me rolling a 5? Well, if I call this E, rolling a 5, then the number of possibilities I have in E is equal to 1. There's only one way to roll a 5. And the number of possibilities in my sample space, whoops, in my sample space is 6 because there are 6 sides on a dice. So the probability of rolling a 5 is simply 1/6. Okay, what about rolling a number equal to or smaller than 2? If I call this E2, well, how many different ways are there to roll a number equal to or smaller than 2? Well, I could roll a 1 or I could roll a 2. So there are 2 different ways for this to happen. And again, the number of elements in my sample space is 6, since there are 6 ways to roll a dice. So the probability of me rolling a number equal to or smaller than 2 is equal to 2/6, or 1/3. All right, suppose I have 12 baseball caps and 28 fashion hats. You have a lot of hats. If you pick a hat at random, what is the probability of picking a baseball cap? So my total sample space here is the total number of hats and caps I have. So my sample space is 12 plus 28, which is 40. And the event that I am trying to determine the probability of, I'm going to call it E3, is the probability of picking a baseball cap. Well, I have 12 of those. So the probability of picking a baseball cap is 12, that's the number of baseball caps I have, divided by the total number of things I'm choosing from, which is equal to 6/20, or 3/10. So if you pick a hat at random, there's a 30% chance that you will choose a baseball cap from your collection. And finally, we want to determine the probability that I choose a state in the US at random that begins with the letter I. Okay, well, my sample space is the number of states, right? So I have 50 states. And my event here is that my state starts with the letter I. So let's see, how many states start with the letter I? Illinois. I did not spell that right, did I? I guess that is right. Illinois. Indiana. Iowa. I think that's it. So there are 3 states here. So my probability of choosing a state that starts with the letter I is 3 out of 50. So to determine the probability of something when all of the outcomes are equally likely, I take the number of elements in that set that I care about and divide it by the total number of elements um, in the sample space. All right, that's it for this lesson. Go on over to lesson 34.